Welcome back to our YouTube channel. If you are a new subscriber, do not forget to subscribe, turn on your notification bell, like, comment, and share. Today, we are back on another concept in chemistry, and today we are looking at the concept of periodic table. Now, I'm taking this topic because this topic cut across many topics in chemistry, and I'm taking my time to take us deep into this concept and to bring us to a high level of understanding of this topic. So let's go into the topic. Today we are looking at periodic table. First thing, what does periodic table means? And that is the first thing that I want us to check in this place. Periodic table can be divided into two words. It's made up of periodic and table. And when you look at the word periodic, the word periodic means when something will occur at regular interval. When something will occur at regular interval, we say that thing is periodic. For example, the blood that comes out of the body of a female, alright, it comes at a certain time of the month. It comes at that regular time. So we say that thing is periodic. Also, in our school, we have different period that we allocate based on our timetable, and each subject is fixed at a particular time. But because that subject is always taken at that time, we say that period is assigned for that subject because that subject is taken at that time regularly. So when something occurs at regular intervals, that thing is what? Periodic. So let's bring the word periodic into the concept of what we want to do today, which is what? Periodic table. So when you join table with it, so we are talking about periodic table is a table which contains the arrangement of elements in such a way that their properties will occur at regular interval. So this table contains all the elements that have been discovered so far in chemistry. And if you look at this topic that we are talking about, this table that we are talking about, we said the elements are arranged in such a way that their property will occur at regular interval. That means that the way this table is designed in such a way that elements that have the same property and that property will occur at regular interval. That means that property, you will see it in other elements. So elements that have the same property, that their property will occur at regular interval. That means that they have the same property, and that property it occurs often in the same way. Those elements are arranged on the same place in the periodic table. So let's go to the properties that they occur at regular interval that makes elements to be placed in the same place in the periodic table. So first, let's go to features of the periodic table that tell us the orientation of the periodic table and how elements are arranged based on the occurrence of their properties. Now, feature that we can see, or one of the features that we can see in the periodic table is what we call groups. And this is the vertical arrangement of elements in the periodic table. It is divided into 8 vertical columns. Now let's go back to our table. If you look at this table, we have 8 vertical columns. We have, if you look at it, we have 1, we have 2, then we have 3, 4, 5, 6, 7, 8. That is 8 vertical columns. All right, then we have period. That's another feature in the periodic table. It said this horizontal arrangement of elements from left to right is divided into 7 horizontal rows. So let's go back to our table. So we have 1, 2, 3, 4, 5, 6, 7. So our periodic table is also divided into 7 horizontal rows. Now, how are elements arranged into groups and periods? Because we say that elements that are they have the same, or that their property will occur as regular interval, are placed on the same place in the periodic table. Now let's look at firstly the groups, we have 8 vertical columns, and in each of these columns we have elements in different group. We have group 1 from group 1 to group 8. Now let's look at group 1. Now elements that we find in group 1, that means that they will have what? The same property that reoccur as regular interval. So what is that property that reoccur at regular interval that makes us to put each element in the same group? For instance, we said note elements with the same number of valence electron belongs to the same group. So that property that makes us to put elements in the same group is their number of valence electron. And when we talk about valence electron, we are talking about the last electron in an element. So if we write the electrical configuration of an element, the last electron that is in an element is also called valence electron. Now let's give instance. Let's look at some elements in group 1. So in group 1 now we have lithium, sodium, potassium. For instance, for the reason why we place and all the elements in group 1 from hydrogen to lithium to sodium to potassium, down the group like that, all the elements in group 1, their property that occur in regular interval, which is the reason why we place them in the same group, is that they have the same valence electron, which I call the last electron. So the last electron in all these elements is 1, and that is their property. Is because they have 1, and that property of 1 they occur in all those group 1. You see 1 1 1 1 1. You see that regular pattern. That is the occurrence of that property, and that property is the valence electron, and which is 1. So all elements in group 1 have 1 electron as their valence electron. For instance, let's do that for sodium. For sodium is number 11. Sodium is number 11. So I want to write the electron configuration of sodium for us. Sodium is number 11. Now for sodium number 11, the electron configuration is 2 8 2 8 1. So now the last electron, which is the valence electron, is what? Is 1. Now another element in group 1 is lithium, and lithium is number 3. The atomic number is 3. So if you write the electronic configuration of lithium, that will be what? That will be 2 1. So the valence electron, another element in group 1 is potassium. Another element in group 1 is what? Is potassium. So if you write the electron configuration of potassium, that will be 2 8 8 1. So what is the valence electron? Is 1. So we see that this property of 1, it will occur for all the elements in group 1. That's what we call periodic. When something will occur, we see that this 1 is reoccurring. We have that regular pattern in all the elements in group 1, and that is why we place them in group 1. So elements are placed in the periodic table based on the reoccurrence of their property. So for groups, elements that have the same number of valence electrons, that their valence electron reoccur as regular interval, are placed in the same group in the periodic table. For instance, now we have let me go to group 2. From group 2 we have beryllium. Be, and that is atomic number 4. If you write the electron configuration of beryllium is what? That will be 2 2. The electron configuration is 2 2. So what is the last What is the last valence electron here? The valence electron here is what? Is 2. So let's go to another element in group 2, and that is what? That is magnesium. Another element in group 2 is what? Is magnesium. Yeah, we have magnesium. I want to write the electron configuration so we can see. That will be the electron configuration of magnesium is what? Is 2 8 282. 282. Now it's 282. So now the valence electron here is also what? Is also 2. That means that beryllium and magnesium have the same valence electron that they occur at regular interval. So beryllium and magnesium can be found in what? In group 2 in our periodic table. So I've talked about group. Let's come to period. Now for period is element that belongs to the same period. We have the same number of shells. Now for instance, let's bring the concept of sodium. Now if we have our sodium, we want to look at the period that sodium belongs to in the periodic table. If you look at the number of shell of sodium, sodium is 281. This is 1, 2, 3. These two electrons will be in the first shell. This 8th electron will be in the second shell, and this one will be in the third shell. So the number of shell of sodium is 3. Is 3. Let's come to magnesium also. Magnesium, our Mg is our magnesium. Magnesium Mg. Now it will also be in what? Magnesium will also be in period 3 because it also have what? 3 shells. Our magnesium also have what? 3 shells. This 1, 2, 3. The 2 electrons will be in the first shell, the 8 electron will be in second shell, and 2 will be in the third shell. Now let's come to element that will be in period 2. Then we go to our table to check if truly they are in that period. Now we want to come to beryllium. Beryllium, the number of shell is what? 1, 2. So it will be in period 2 because the number of shell is 2. We also have lithium. Lithium, the number of shell of lithium is also what? Is also 2 because this is 1, 2. This first 2 electron will be in the first shell. This 1 electron will be in the second shell. The number of shell of lithium is also what? 2. Now, so let's go back to our table to verify. Now, if you go back to our table, you see that our beryllium is in period 2. This period 2, and our lithium is also in what? Period 2. So let's come to sodium. Sodium is period 3. You see 3 here, and our magnesium is also what? Period 3, because they have the same number of shell. So that is how we place elements in the same group and the same period based on their property that they occur at regular interval. For group, their valence electron is their property that they occur at regular interval. They make us to place them in the same group. And for period, they have the same number of shell. Elements that have the same number of shell have this their property they occur at regular interval and place them in the same period. Now, so let's go to another features in the periodic table. These blocks in the periodic table. So periodic table is also divided into blocks. That's another feature in periodic table. And we have our S block, we have our P block, we have our D block, and we have our F block. So we see the color for S. Those that have this color, they are in S block. The P block, these are elements that are in what? In P block. For all this color is for P block. Elements that are in D block, they are elements that are here, and elements that are in F block, they are the elements that are here. So how do we place elements in what? In the same block? Elements that have this that belongs to the same block are elements that their valence electron last in that what? In that orbital. We have what we call SPD and F electronic configuration, which we also call subshell electronic configuration. When you write the electronic configuration of SPD and F, if the last electron of an element falls in the S orbital, that means that that element will belong to S block. If we have the electronic configuration of an element and the last electron ends in the P orbital, that means that that element will be in the P block, and so on and so forth. Now, let's take, for example, let's write the electronic configuration of elements and see the block that they belongs to. For instance, let's take sodium. For instance, let's take our sodium. And now, if you take our sodium, this sodium, we want to write the SPD and F electronic configuration so that we know the block that sodium belongs to in the periodic table. Our sodium is number 11. So if you look at our SPD and F electronic configuration, the S orbital cannot carry more than 2 electrons. The P orbital, the maximum electron it can carry is 6. The D orbital the maximum of electron it can carry is 10. And for the F orbital, the maximum electron it can carry is what? Is 14. Now, based on that number of electrons they can carry is how we'll be able to assign, how we'll be assigned the number of electrons to those orbitals. So let's write, there is a pattern of how we arrange the structure of the table. So we want to write the electronic configuration of some element and know the block that they belongs to in the periodic table. Now, this is the table that we use, or this is the diagram that we use, or the pattern that we use in writing the SPD and F electronic configuration of elements. And know that for the S orbital, it cannot carry, the maximum of number of electrons it can carry is 2. For P orbital, it cannot carry more than 6. For D, it cannot carry more than 10. And for F, it cannot carry more than 14. For instance, let's write the electronic configuration of sodium. And knowing that sodium is number 11 in the periodic table, the atomic number is 11. Let's write the electronic configuration of sodium. This is how it follows. You see the arrow coming down, you'll be picking the orbital as the arrow is going down. You'll be following how the arrow is going down, and you'll be picking those orbitals. You'll be writing the number, you'll be assigned the number of electrons that is available to them based on the element that you want to write. For now, for sodium, we pick first 1s, which is the first orbital there, 1s, and our s can carry 2. You know, we are going to 11, so we assign 2 there. That is, we have 1s2. Then we come to the second orbital, that is 2s2. We write 2s2 because our s can carry the maximum of 2, and we have not gotten to 11. So the next one is 2p. So we write 2p, this 2p, and our p can carry 6 electrons. So we assign 6 electrons to that, our 2p. So that is 6 electrons. 2 plus 2, 4 plus 6, that is 10. We need one more electron because our sodium is number 11. So we come to the 3s orbital. We'll be following the arrow. So we have 3s, but we only have 1 electron left. Our s can carry less than 2, but it cannot carry more than 2. We assign 1 that remains to s orbital. Our sodium will belongs to s block in the periodic table. Why? Because the last electron that we assign is assigned to what? To the s orbital. It was assigned to s orbital. How do you know the block that an element belongs to in the periodic table? By looking at the last orbital signifies the block that the element will belongs to in the periodic table. So the last electron assigned to this orbital, we assign it to what? S orbital. So our sodium will be in what? In the s orbital because our s is the last orbital that we assign our electron to. Let's go to another element. Let's take for instance nitrogen. Nitrogen is number 7. So let's write the electron configuration. We start from 1s, 1s2, nice, 1s2, then 2s2. We come to the second orbital, 2s2, that is 4. 2 plus 2, 4. We are going to 7. So we have 3 electrons left. We go to the next orbital, which is 2p. So we come to 2p. Now it's a mixed 3. So that will be 2p3. It can carry less than 6, but it cannot carry more than 6. It depends on the electron we want to write. The last electron that we assign is what? Is assigned to the p orbital. So that means that nitrogen will be found in p orbital because the last electron that we assign is to the p orbital, and sodium we find in the s orbital because the last electron that we assign is to the what? To the s orbital. So it will be found in the s block, and nitrogen will be found in the p block. Let's take maybe 1 or 2 more. Let's take for scandium. Scandium is an element in the periodic table. Let's look at the block that scandium belongs to in the periodic table. But because the electron configuration is long, we used to write something like this. Our noble gases, for instance, we are going to reach 18 before we are going to scandium, and scandium is 21. So we write the noble gases before the elements that we want to write. So this is 18. That argon is 18. So we are left with 3. So argon is 18. If you look at it, we are going to our 18 will be 3p because 1s is 2, 2s is 2, that is 4, 2p is 6, that is 10, 3s is 2, that is 12, 3p is 6, that is 18. So the next orbital that we need to write is 4s. So we write 4s2. Our s can carry 2, 4s2. Then we move to the next orbital because it is from top to down. 3d. So how many electrons remains? This is 18. This is 18 plus 2, 20. So it remains 1. So I will assign 1 here. So our last orbital here is what? That I assign my electron to is D. So the last orbital that I assign electron to is the D orbital. That my scandium will be in the D block because it is D orbital that I assign my last electron to. So how do you know the block that an element belongs to in the periodic table? You write the s, p, d, and f orbital, and you look at the last orbital that you assign last electron to will be the block that element will belong to in the periodic table. So my sodium is in s block, my nitrogen is in p block, my scandium is in d block. If you want to know the element that belongs to f block, if you write the electron configuration and the last electron that you assign, it falls to the f orbital, that means that element will be in the f block in the periodic table. So that has been goes to the end of how to recognize which block that an element will belongs to in the periodic table. Now, so let's go to the next thing. So we have here elements in the same block have the same valence electron in the same orbital. Yeah, so if an element is in D block, all elements in D block, that means that their valence electron ends in what? In the D orbital. If all elements in S block, that means that their last electron ends in the S orbital. That's what we are trying to say here. Now, let's come to families in the periodic table. Now let's look at group 1. Group 1 elements. All elements in group 1 are metal except hydrogen. Hydrogen is placed in group 1 not because it's a metal but because its valence electron is 1. You know, I've explained that if the valence of electron of any element, if they are the same, they will be placed in the same group in the periodic table. So hydrogen has 1 electron, so the valence electron is also 1. That's why it's placed in group 1, not because it's a metal. So all group 1 elements are metal except hydrogen, and they are called alkali metal because the metal in group 1, if we dissolve them in water, they form an alkalis. Let's come to group 2. All elements in group 2, they are all metal. They are called alkaline earth metal. Why? If you dissolve them in water, if you dissolve any metal in group 2 in water, they are also going to form an alkaline. And the reason why earth is inputted into it is because they are found in the below the earth crust. All these elements in group 2, they are found below what? The earth crust. And when you dissolve them in water, they are going to give you an alkaline solution. That's why we call them alkaline metal. And because they are found under the earth crust, that's why we input earth there. Now let's come to group 3. In group 1, if you go to group 1, go to your periodic table, you see element that belongs to group 1, and group 2 also. Check your periodic table, you see element that belongs to group 2. For group 3, all are metal except boron, that is metalloid. So all elements in group 3 are metals except boron, that is metalloid. Let's go to group 4. And from group 3, we have elements like aluminium, boron, and gallium, and so forth. Aluminium, that is an element in this group 3. Aluminium, the oxide of aluminium and the hydroxide of aluminium, they are amphoteric. Yeah, that's one peculiar characteristic of aluminium, which is part of group 3 elements. The oxide of aluminium is amphoteric. The oxide of aluminium is also what? Amphoteric. What do we mean by amphoteric? Amphoteric means that substance that can act as an acid and can also act as a base. The oxide of aluminium and the hydroxide of aluminium can act as both acid and as bases. Let's go to group 5. Only nitrogen and phosphorus are non-metal in group 5. So as you're going down the group also, you are moving from non-metal to metalloid and to metals. So the most prevalent element in this group 5 that we talk about is mostly nitrogen and phosphorus. For group 6, we have oxygen, sulfur, and selenium. They are what? They are non-metal in what? In group 6 also. As you are going from group 6, in group 6 also, you are moving from non-metals to metalloid and to metal. So it's only oxygen, sulfur, and selenium that is non-metal. That means that the next element will be metalloid. As you are going down the group, you are going towards what? The metallic what? Element. And we come to group 7. All elements in group 7 are non-metals. It's only in group 7 that all the elements in group 7 are what? They are non-metals. So they are pure non-metals, and they are called halogen group. Yeah, they are called halogen group, and they are what? Salt former. What do you mean? All elements in group 7, if we add them with metal, they are going to form a salt. Any element in group 7, when they react with metal, the resulting compound will be what? A salt. And that's why we said that they are what? They are salt former. All right, let's go to the last group in the periodic table. We call them group 8 or group 0 element. Why? And the name that we give to them is what? We call them rare gases or inert gases or noble gases. Why? We say they are called inert or rare gases because they rarely participate in chemical reaction. This is because their valence shell are completely filled already, or they are filled already. Yeah, this is because their valence shell are filled already. We can remove the word completely. Yeah, there was this because their valence shell are filled what? Already. All right, why are these elements called rare gases or inert gases or noble gases? It's simply there. is because they rarely participate in chemical reaction. We know from our basic chemical reaction that from our basic chemical concept that before an element can participate in chemical reaction, that means that that element have incomplete what valence shell, and it's because they want to have elements now participate in chemical reaction so that they can have their valence electron completely filled. What do you mean by that? By having 8 electrons in their outermost shell. That is why elements participate in what? In chemical bonding. They share or they transfer their electron in order to have completely outermost shell, which is what? 8 electrons in their outermost shell. Mostly 8 electrons in their outermost shell. But for these elements that are called noble gases, they already have 8 electrons in their outermost shell. Which element that participates in chemical reaction wants to achieve? They already have it. And because they already have it, there is no need for them to actually participate in any chemical reaction again, because they already have 8 electrons in their outermost shell, or they have duplet states. Some duplet state, that means that duplet state, our stability can be duplet and can be what? Octet. Those that have duplet state, that means that their outermost shell is only what? Is only 2. Yeah, it's only 2. This one they can exhibit the stability of 2, and but apart from that, other will be exhibiting the stability of what? 8. So the group 8 elements, they rarely participate in chemical reaction because they already have the exact number of electrons they need to have in their valence what? Shell. So let's go to the last concept in this periodic table, and we are coming to the concept of trends in the periodic table. We call it periodicity in periodic table. We are talking about the variation in what? In property that occurs what? Within the periodic table. So what is atomic radius? The radius of an atom is the distance between the center of the nucleus and the outermost electronic shell. Ionization energy is the energy required to move the most loosely bound electron from a gaseous atom against the attraction of the nuclear charge to form a gaseous ion. What is electronegativity? This is the ability of an atom to attract shared pairs of electrons to itself in a molecule. What is electron ability? This is the measure of the ability of an isolated gaseous atom to gain electrons. This is the energy change. It can also be defined as what? The energy change that occurs when an isolated gaseous atom gains an electron. All right, so let's go to the summary now, and this is where I'll quickly explain here the summary of this trend in periodic table and how to quickly know how to answer question on this aspect. But explain a full video on trends in the periodic table as second part of this periodic table that I will deal with in my other video concerning periodic table. Look at this place now. How they ask question in the examination hall is to ask us that what happens to atomic radius if it's moving from left to right across the period, or if it's moving down the group. Now look at this table. I've given us clue. Only atomic radius increases down the group and decreases across the period. Now if they are asking us question concerning this 4 trend in the periodic table, all other trends, which is ionization energy, electron negativity, electron affinity, they all decreases down the group. Only atomic radius increase down the group, and across the period only atomic radius decreases across the period, or increases across the period. Only atomic radius decreases across the period. So how the question is always framed is to ask you of how this trend, how did they behave down the group and how did they behave across the period. So just master this table so that you can provide the answer anytime they ask question on this session in the periodic table. Now I want to leave us with an assignment which I want you to drop in the comment section or in the comment box. Give me the difference between electronegativity and electron avidity. Yeah, I just want to give me the difference. They look similar, but they are different. Yeah, they are different. If you look at the definition, you may seem as if they are saying the same thing. No, they are different. So I want to give you the difference in the comments box before I do a complete video on trends in the periodic table to explain better the concept of trends in the periodic table. I believe if you have followed me through this topic, you will have gotten a deeper understanding of what periodic table is and how to answer question in periodic table when you find it in the examination. Or thank you for following me through this section. I want to let you know also that if you want this video to be of benefit for other people, do not forget to first thing, like this video, share it with your friends, turn on your notification, and do not forget to also subscribe to this YouTube channel to promote this channel and to also have access to other educative content that will be dropping on this channel.